Assalamualaikum warahmatullahi wabarakatuh. I am Tengku Nur Ainadia binti Tengku Syaiful Baril, matrix number 192436. Today I'm going to present about the last lab report, the last week for the lab report, which is exercise 7, titled Analyze Boiler System. Lecturer is Encik Muhammad Yusof bin Harun. Date of experiment is 6 December of 2018. We are from group 12. I'm going to present my part, which is introduction. The introduction of this experiment is um, I'm going to explain about the steam boiler system. Steam boiler system is a closed vessel which an amount of water is heated by some source of heat to produce a very hot steam. The water inside the tank is controlled by adjusting the pressure inside the tank. A steam boiler system is also a non-linear, time-varying, multi-input and multi-output system, which is generally has variation with the operating conditions. In fact, a steam boiler should have a minimum capacity of 10 liters of water in the tank. Um, the steam boiler that we use is the Marset boiler. Marset boiler is used to find the relationship between the pressure and the temperature of saturated steam in equilibrium with water at all temperature levels.
Okay, hi, my name is Ryan Zaira. Today I'm going to talk to you about the working theory of this experiment. This experiment is to design and investigate the relationship between pressure and temperature of saturated steam. Ideal gas follows the equations of states which relates pressure, specific volume, absolute temperature. The equation is PV equals to MRT over M. From the theory, we can know that when energy increases, the molecules move faster and the number of molecules escape higher until equilibrium is reached. The experimental slope obtained is compared to the theoretical value from the steam table. This is the Clausius-Clapeyron equation that is used in this equation, where Vf is the specific volume of water, Vg is specific volume of steam, Hf is the enthalpy of water, meanwhile Hg is the enthalpy steam. Hfg is the latent heat vaporization. In the states of equilibrium, depends on the pressure of water surfaces and steam. Less energy will be required to achieve equilibrium as it is easier to lift the water surfaces. Um,
The materials that we use is a Marset boiler. This is the image for the Marset boiler, and the next to it is the cross-sectional view of the Marset boiler. And then I'm going to explain about the methods. The methods is just simple. Firstly, the boiler is prepared for the heating and cooling process. Next, the readings of the temperature is taken at the initial pressure once the steam is showed up. And the third one is the steps are repeated for the cooling process after that. And the last one is experiment is observed carefully and recorded.
Okay, my name is Wana Zahadana. My matric number is 19, 20 and 32. So I will explain to you guys about the result from our experiments, which is this one is the process which we use the temperature the pressure of 1 bar, 2 bar, 3 bar and 4 and 5 bar. So we got the temperature for the pressure, which is 120, 139, 149 Celsius, 158 and 166 Celsius, for the heating process, and this is for the cooling process. So this is the data that we would like to use if we want to plot the graph. So this is my first graph, which is temperature versus pressure. This line is for for the cooling part, and this one is the heating part. Then this is the graph, which is log T versus log P. Uh, we have get the log P and log T from the table above. So this is the graph for 1 over temperature of versus ln P. So ln P is on the horizontal part and 1 over T is on the vertical part. Okay, from the figure 1.1, which is the graph 1.1, it is clearly shown that the temperature increased with the increase of pressure, and pressure and temperature is directly proportional to each other. And from the graph number 2, we can see that log P increase once the log T increase. Log P and the log T is directly proportional to each other. And from the figure 3, which is graph 3, we can say that ln P increase when 1 over T will decrease. This is mean that ln P and 1 over T is inversely proportional to each other. So this is the table for the comparison between the T that we get from our experimental and the T from the table A5. This is the pressure that we use, and this is in kilopascal, and this is in bar, and this is the temperature saturated temperature from the table. So this one is the graph, which is the average versus pressure, and this is the T average from the experimental, and this one is the T set from the table above. So that's all from me. So I will pass to my friends.
Okay, my name is Nur Zalaika. Based on the graph above, we can clearly see that the graph for temperature average is more higher compared to saturated temperature. This experiment error may be occur based on the condition of the machine. The boiler still release out the steam, although the chamber is already closed. Air should be expelled from the boiler, because if the air is not expelled, the correct equilibrium measurement between the steam and boiling water will not be obtained. Due to the partial pressure of air, lower water temperature will be required to raise the pressure. Um, some possible error of this experiment is the reading accuracy, the stability of material, the room temperature and pressure. The water in the boiler is from lower temperature. When it is started to heat up, the liquid molecules move faster as they gain heat. All the molecules started to fly apart and become gas. As the liquid absorbs enough energy, it changes to vapor form. Some examples of boiler found in the industry are power plant boiler, gasifier, water boiler, steam engines, fluidized bed reactor. The purpose of safety valve is to open and relieve excess pressure from the boiler, and to reclose and prevent the further release of fluid after normal conditions have been restored. Blow-off valve allows blow off excess quantity of steam to atmosphere.
The conclusion is the relationship between the pressure and the temperature of the saturated steam is presented in a graph. Besides, the temperature of the saturated steam and pressure are compared using the steam table data. The objective are all achieved. It is found that the pressure is directly proportional to the temperature of the saturated steam. The higher the pressure inside the tank to force the rising of the steam temperature, the higher the temperature. There are some errors which are less repetition for the experiment cycle, the thermometer reading, and the valve closing. There are some recommendation to complete the experiment. Firstly, is the step must be repeated at least 3 times to get average data for the proper results.